Hello everyone, I'm Mike Goldstein, and in this video we will be performing a double displacement reaction in the online software called Late Night Labs that you will be using throughout your course. In a double displacement reaction, two aqueous solutions containing dissociated ions are reacted, and the cations, or the positive ions, of the initial compounds switch places to form entirely new chemical compounds. Let's begin the experiment, and we can explain more of the details as we go and conclude after. So, firstly, in terms of apparatus for the lab, we will need two 50 milliliter beakers. These can be obtained by clicking on the Containers tab as seen here and dragging them each to our virtual workspace. Next, click Materials tab and we will add 15 milliliters of 1 molar sodium hydroxide into beaker 1 and then 6 milliliters of 1 molar nickel 2 chloride NiCl2 into beaker 2. We recommend double-clicking your beakers and labeling them according to which solutions are inside. And for the second one, NiCl2. So, some observations. We observe that the sodium hydroxide is clear and colorless initially, and the nickel 2 chloride is a clear green. Here comes the fun part. If we drag one of our beakers onto the other and transfer all of the solution, then we can see that a reaction occurs. A solid green precipitate forms, and liquid around it becomes clear. If we want, we can zoom in and decant, or separate the solid from the liquid to observe more clearly. The reaction is a precipitate reaction that my partner will explain in more exact terms after we clean up our virtual workspace.
Hello everyone, I'm Ransom Conant. Here we have the balanced chemical equation of our reaction, which is a double displacement precipitation reaction. As you can see, we have 2 moles of sodium hydroxide reacting with 1 mole of nickel 2 chloride to yield 2 moles of sodium chloride and 1 mole of nickel 2 hydroxide. All of these are aqueous except for our precipitate, nickel 2 hydroxide. To investigate this equation further, we'll look at the total and net ionic equations. In the total ionic, we can see that the sodium hydroxide dissociates completely due to it being a strong base. The nickel 2 chloride and the sodium chloride both dissociate completely as well because, save a few exceptions, chloride anions cause the compound to dissociate completely. Nickel 2 hydroxide, however, does not dissociate and remains in its solid form. It is not soluble due to the hydroxide anion. We can cross out our spectator ions on either side of the equation, which are sodium and chlorine, in order to find our net ionic. This displays the true reaction that occurs. 1 nickel ion combines with 2 hydroxide ions to form 1 molecule of solid nickel 2 hydroxide.